Alright, so this time we have to find the complex power of the load. So we do want to pay attention to which thing it is that we're looking for. And, oh good, I did want to do this one. And to find the complex power for the load, I have Z for the load already. So if I could get the current for the load, then the complex power just like we had when we had just real power, we had P equals IV. If I have and V equals IR, and so I could come up with all of the other formulas for power using that. So like I could have P equals I squared R. So if I have complex power equals V I conjugate, and V equals I times Z, then I can replace V with IZ, and I times I conjugate is the magnitude of I squared, so complex power is I squared Z. So if I can get the current and already have Z, then I'll have everything I need to get the complex power. So I'll do a little mesh analysis, and I'll call this I1, and this I2, and this I3. And I'll write my mesh equations. So my voltage is minus 15 angle 45 degrees. And then R1 was 5. So plus 5I1. Our capacitor was minus J1. That was weird. And so that'll be minus J1, I1 minus I2, and that equals 0. Okay, and then my second mesh, I will have minus J1 times I2 minus I1. My inductor was J2, so plus J2 I2 plus R2 is 2 ohms, so 2 I2 minus I3 plus 2, and now notice I right here, I is the current through this inductor, so I is the same as I2 because that's I2 up there. So plus 2 I2 equals 0. And then for I3, I'll have minus 2 I2 plus R2 was 2, and that would be I3 minus I2 plus I3 times ZL was 6 plus J4 equals 0. Alright, so now I will have 5 minus J1 I1 minus I2 plus 0 equals 15 angle 45 degrees, which is I won't figure that out right now. Okay, and then my second equation, I have minus J1 I1, and then for I2, I have minus J1 plus J2, that just gets me J1 plus 2 I2, and minus 2 I3. And I have something wrong. This should have been plus, because a minus times a minus is a plus. That's a plus. That's a plus I2, plus JI2, plus 2JI2. It's 4I2. Yeah, I can't subtract. Let's try this again. That is 2 minus 1 is 1. Got it. And 2 plus 2 is 4. 4 plus J1 I2 minus 2I3 equals 0. And then my last equation, I have no I1s, 0 I1, minus 2 minus 4, minus 4 I2, and plus 8, yes, plus 8 plus J4 I3 equals 0. Okay, so you might be wondering, well, how am I going to solve this? And so one of the reasons I wanted to do this is I wanted to show y'all how to solve this in MATLAB. Have y'all used MATLAB yet? Oh, is it? Okay. Well, I'm doing it just kind of a brute force, straightforward way. I'm not doing anything fancy. So I think the easiest way to do this in MATLAB is if we think of this as a matrix like that, then if I take the inverse of this matrix times the column vector on the other side, then I'll get I1, I2, I3. So I will just say A equals so I put in the first row separated by commas and then a semicolon using I for J. and then a semicolon. And there we go. And then matrix B will equal 15 times 0.707 plus I times 15 times 0.707, comma 0, comma 0. And then I want A inverse times B. And I wanted I needed semicolons. So B I needed to define not with commas but with semicolons. I needed it to be a column vector. And so that gets me my I1, I2, and I3. So and then what was I looking for? The complex power of the load, so that would be I3. So I want S equals 1/2 absolute value of I3 squared times ZL. So that would be and ZL was 6 plus J4. And that's not right. You know, one day, no, I just get worse each day. So it's like it's gonna say one day I'll be able to do this without making so many typos, but that's not gonna happen. So there it is. Okay. And this is the complex power, and so the complex power is VA. So the reactive is VAR, that's all imaginary. Complex that has a real and an imaginary part is VA. So questions on that?